Well, hello guys, here Mr. G with another video for the grade 10. This is going to be another question related to paper 2, so you can it can help for the upcoming exams. But before you watch the videos, don't forget to subscribe to the channel so you can get all notifications I post on the regular basis. This was question 4 from June 2013, done at the Northern Cape, and it is a set B. It was related to atoms and standard notation, as you can see here. The question says, consider the following hypothetical atoms and ions, and then answer the subsequent questions. The letters are not the symbol of real atoms, so this doesn't represent real atoms. These are hypothetical different atoms or ions. Okay, so question 4.1: which two atoms or ions have the same amount of protons? And guys, this one is related to standard notation. I just want to remember you that the standard notation is represented in the following way, in which this one is the element. Here at the bottom you have letter Z, which represent the number of protons, and here you will have letter A. I'm going to write what is the meaning of each of them. Z stands for atomic number, which in other words is the number of protons. This one here is number of protons. This is just recalling number of protons. And A stands for the number of atomic mass, which is the addition of protons plus neutrons. So this A here is the atomic mass. And just for you to remember, atomic mass, which is A, will be equal to the addition of Z plus N, which are the neutron. And guys, E is the element. E is just the element. So having this little recap, now you will be able to answer this one very simple. So we're looking for the same number of protons, therefore it is Z, and that is, guys, the number at the bottom. So you can see that the only one that have the same number of protons are A and B. Let's write that and properly, and B. Alright, so those are the two elements, in this case are the two atoms that have the same number of protons. Which two atoms have the same amount of neutrons? Now guys, if we go back to this equation here, A is equal to Z minus N, the neutrons can be calculated by subtracting A minus Z. In other words, the atomic mass minus the atomic mass. So in each of them, for instance, here it will be equal to 37 minus 17. That will give you the number of neutrons. That is the number of neutrons. In this case will be equal to 20. That is neutrons. If we go to B, we have, which is 35 minus 17. So the number of neutrons today is going to be equal to 18. Now guys, I want you to note the following here. This number here, the minus 2, is going to be only affecting the number of electrons. So it doesn't affect neither the number of protons or neutrons. So we can say here, guys, that which two atoms have the same number of neutrons. So that will be, that's speaking about atoms. So I want you to make sure this, they're speaking here about atoms, and E, even though it have the same number of neutrons, this one is an ion. So be careful with that. And this one here is an ion. It's an ion because it has a charge, as you can see. That is because it has given away 2 electrons. So the two atoms they're speaking about here that have the same amount of neutrons would be A and D. It's quite simple. You see how to calculate. Name 3 similarities between A and B. Okay, so we are dealing here with A and B. Now, what do they have the same? First of all, they have the same number of protons, which is the atomic number. So the first similarity we're going to mention here is that they have the same number of protons. Now, important, if they have the same number of protons, it means that they belong to the same element. So, because they have the same number of protons, there is no other way that they could be of different elements. So they are same element. And finally, because these two atoms here, both of them are neutral, and both of them have 17 protons, they will also have 17 electrons, each of them, because they are neutral. So as you can see here, they also have the same number of electrons. This one is quite simple. I hope you understand. Now, in question 4.4, they say we now give two differences between A and B. Okay, so we're going to be doing it here. For A, the atomic mass, is 37. For B, the atomic mass is 35. So that is the first difference you can see there. That is the atomic mass. The second difference, because of the number of the atomic mass is different, that means that the number of protons is as well different. So let's say here, for A, neutrons will be equal to 37 minus 17, which give you a total number of neutrons of 20. But if you go for B, and you calculate the number of neutrons, which in this case will be 35 minus 17, you get that the number of neutrons is going to be equal to 18 neutrons. Guys, that is the other difference. A have 20 neutrons, but B has 18 neutrons. That is the other difference they're asking you about here. Okay, question 4.5. Explain how it is possible for C and E to have the same mass number. Okay, guys, quite simple, because they have the same different number of protons and different number of neutrons. That's all they have. So all you have to say in that question is they have different number of protons. And neutrons. And you need to know that the atomic mass, remember, it is the A is equal to Z minus N. Remember, in this case, 8 and N and Z are just representing the atomic mass. Okay, so I hope that is quite clear. It is very, very simple. If you want, you can now calculate it, but we did already there. So I am just not going to redo it. We did calculate here the number of neutrons in each case. This is C and E. So that was done there, guys. They have the same number of a different number of protons, but because of the neutrons, they have the same atomic mass. Now, question 4.6. Write down the SPD notation, spectroscopic electroconfiguration notation of ion E. Now, for ion E, what we need to know? We need to know the number of electrons. Now, ion E has it had 20 electrons, but this positive 2, it means that it gave away 2. So ion E will have now 18 electrons. And you need this one, otherwise you cannot do the spd notation. So in this case, we're going to level 1 orbital s, and there is going to be 2 electrons. We're going to energy level 2 orbital s with also 2 electrons. We go to energy level 2 orbital p with 6 electrons, and you make sure you start counting now. There is 10. So we still go to energy level 3 orbital s with another 2 electrons, and energy level 3 orbital p with another 6. You make sure you recount. So it's 2 plus 2 is 4 plus 6 is 10, 12 and 6 is 18. This one is the spd notation for this ion E, guys. It's quite simple. Now, question 4.7, the relative atomic mass of D is given on the periodic table at 39,453. Give a reason why this is a decimal number. This is quite simple, because the relative atomic mass is the average mass of all the isotopes of an element. It's very simple, guys. So all we have to say here is that the relative atomic mass is the average mass of all the isotopes of an element. Guys, this is the end of question 4. I hope it helped. It's a good question to practice because this is a lot of things related there. But thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.